Hi everybody, we're going to do a little video on quadratic equations, and we're going to look at discriminants and roots. This is towards the end of the first or the second week of the course, the first week of the mathematics, and it's quite a common type of question to appear in exams, so it's definitely worth spending a little bit of time thinking about discriminants and roots. Okay, so let's just think about what we mean by a discriminant. Okay, and I'll take your mind back to the idea of the quadratic equation. Of course, when we talk about quadratic equations, that's my example. Let's get my pen working. Then we're taking a quadratic, ax squared plus bx plus c. And x is the unknown, so we're looking for some number to fit this equation. And a, b, and c are constants. In other words, they're just numbers. So it could be 2x squared plus 3x minus 5 equals 0. And in that equation, 2x squared plus 3x minus 5, we're looking for an x or x's which will satisfy the equation. In other words, make the equal signs work and make it equal to 0. And the quadratic formula allows us, if you look back through the lesson, to find a formula which gives me those answers, which is very convenient. So the formula tells me that if I plug in the values a, b, and c to this formula, I get the answers to the equation, or the solutions rather, to the equation. Solutions, you notice, plural. Because of the plus and minus, I could have more than one solution to satisfy this equation. And this value x, if I plug it in here, will get me 0. Of course, this formula comes from completing the square of this equation. So that's an interesting way to look at the proof of the quadratic formula. Now, the really interesting thing about the formula is this part here. We see the square root, and what we know is that I don't have a real number available to me that if I multiply by itself will give me -5. Remember what a square root really is. A number multiplied by itself which gives me the number in the square root. So square root of 9 is 3 because 3 times 3 is 9, and so on. Square root of 2 is not so easy to work out. It's 1.414, etc., etc. But if I multiply by itself, I'll get back to 2. -5 is a problem because I can try two positive numbers. Obviously, they don't multiply to a negative. Two negative numbers multiply to a positive, and 0 multiplies by itself to 0. So there's no real number which multiplies to -5. So I don't have a real number which will give me the answer to the square root of -5. What that means is that if I have a negative number inside the square root, I've got a problem, or an issue at least, with my solution to this equation. In other words, the solution doesn't exist in the real numbers. And seeing when I want to plot graphs, if you remember the quadratic equation, or quadratic function, gives me graphs like this. These zeros, these x values here, relate to the x values which satisfy this equation. If they don't exist, it tells me something about this graph. In fact, it tells me it doesn't actually cross the x-axis. Okay, so that's a strong geometric result from this algebraic formula. Okay, so what do we mean here? Well, first thing is, if what I've got inside this bracket, it's in a bracket I suppose, but inside this square root is less than 0, then I can't find the square root for a real number, and that means that I don't get any real solutions to this quadratic equation. In other words, it doesn't cross the x-axis. If this b squared minus 4ac, this thing inside the square root, is bigger than 0, then I will get a solution. In fact, because b squared minus 4ac squared root gives me a real number, I'll add the real number, I'll subtract the real number. In fact, I'll get two solutions, and that looks something like this. Of course, my quadratic graphs can go either way, so it could look like that as well. There's two ways I could get the two solutions. Okay, so here we have a number of solutions. 0, here there are 2, and finally, if b squared minus 4ac equals 0, in that case, this part of the formula disappears, and I just get one solution, and that will be a graph looking something like this. It will just touch here. It didn't touch very well, but there you see what I mean. Okay, or it could be, of course, the other way around. Okay, let's look at an example.